Hi guys, are you familiar with chemical reaction, limiting reactant, excess reactant, and theoretical yield? So, by the way, I am Erma Joy Novela and welcome to my video. So, what I will be tackling today is that I will discuss to you on how to determine the limiting reactant, excess reactant, and the theoretical yield. First things first, I will be defining them. So first is the limiting reactant. So what is limiting reactant? Limiting reactant in a chemical reaction is the substance that is used up first, stops the reaction, and limits the amount of product that can be formed. Second one is the excess reactant. That is a leftover when a reaction stops. So guys, for you also to be able to determine the limiting reactant, excess reactant, and theoretical yield in a chemical reaction, I will show you 3 examples. So, be excited and enjoy learning.
Let us have the problem number 1. What is the limiting reactant, excess reactant, and theoretical yield between 6 moles of CO2 or carbon dioxide and 4 moles of N2 or nitrogen? So how many moles of NO will be produced with the reaction? So let's have the first step, which is balancing the chemical equation. So as you can see guys, it is not balanced. It is not balanced, but I already put 2 here, so for easier. So we already have balanced equation. So we have one carbon here also, and oxygen here is 2, oxygen also here is 2, and the nitrogen here is 2, nitrogen here is 2. So as in the given, we have 6 moles of CO2 set. So let's put 6 moles and the 4 moles of nitrogen. And what is asked is the nitrogen monoxide. So let's have the question mark here. So the second step is we would convert moles of carbon dioxide to the moles of nitrogen monoxide. So we have CO2 to NO. So as we remember, we have the 6 mole of carbon dioxide. So let's put here for us to be able to convert 6 mole of CO2. So let's multiply. So we need to have the, and also we have 2 moles of nitrogen monoxide. 2 moles of NO. So let's divide it by CO2. So we have 1 mole of CO2 here. CO2. So let's cancel this out. So 6 times 2 divided 1 is 12 mole of NO. It is NO guys. So the next step guys is to convert moles of nitrogen to the moles of nitrogen monoxide. So N2 to NO. So as you can see here, we have 4 moles of N2. So it came from here. 4 moles of N2 and times 2 moles of NO. So we have here 2 moles of NO divided by 1 mole of N2. So it is equals to 8 moles of nitrogen monoxide. So let's compare. As we can see in N2, we have 8 moles of nitrogen monoxide, and then the CO2 here, we have 12 moles of nitrogen monoxide. So the smaller one is the 8 mole of nitrogen monoxide. So it simply means that our limiting reactant is the nitrogen, excess reactant is the CO2 or carbon dioxide, and the theoretical yield is the nitrogen.
And as what is asked guys, how many moles of NO will be produced with the reaction? So it is answered by here. So we have 8 mole of NO or nitrogen monoxide. So that is problem number 1.
So let's have problem number 2. How many moles of H2O could be produced from 3 grams of CO2 and 7 grams of H2? So same process guys. So step 1, you need to balance the chemical equation. So in this case, I have already balanced it. And before I balance it, it is only CO2 plus H2. It is without 2 here. 2C plus without 2 also H2O. So for it to be balanced, I put here 2 and here also 2. So it is now balanced. So we have here 1 carbon. And there we have 1 carbon also. And here we have 2 oxygen. Here we have 2 oxygen. And in here we have 4 hydrogen. And in there we have also 4 hydrogen. So as you can see guys, in the given, we have grams, not moles. So able to convert it to moles CO2 divided by the total mass of carbon and oxygen. In the periodic table of elements, for the carbon, it has 32 mass, and for the oxygen, it has 6 mass. But we need to multiply it by 2 here, so it becomes 12. So 32 plus 12, it sums 44. 44 grams of CO2. So we need to cancel this out. So 3 times 1 divided by 44, it is equals to 0.07 mole CO2. Next is the hydrogen. So in the given we have 7 grams of H2. So let's have here 7 grams of H2 times 1 mole of H2 for us to be able to convert it to moles. So divided by 2 grams of H2. So why is it 2 grams? So in the periodic table of elements, the hydrogen has only 1 mass. So 1 times 2. So we have 2 grams of H2. So let's cancel this out. Cancel. So 7 times 1 mole H2 divided by 2 is equals to 3.5 moles of H2. So we already have our converted mole. So in here, our carbon dioxide has 0.07 moles and the hydrogen has 3.5 moles. So we would be able to convert the moles of carbon dioxide to the moles of water already. So CO2 to H2O. So in here, we have the solution already. So 0.07 moles of CO2 times 2 mole of H2O. So why is it 2 moles of H2O there? So we have here from the balanced chemical equation, so 2 moles of H2O divided by 1 moles of CO2, because we only have 1 CO2 from the balanced equation here. So let's cancel this out. So 0.07 times 2 moles of H2O divided by 1 is equals to 0.14 mole H2O. So for the next step is we need to convert the moles of hydrogen to the moles of water. So H2 to H2O. So we have 3.5 moles of H2. And we need to put here 3.5 moles of H2 times 2 mole of H2O over. So we have here 2 mole of H2. H2. So we need to cancel it first. And 3.5 times 2 mole divided by 2 is equal to 3.5 H2O. 3.5 mole H2O. So we have to compare this. And it's time to compare. So in carbon dioxide we have 0.14 moles of H2O, and in the hydrogen we have 3.5 moles of H2O. So the smaller one is the 0.14 moles of H2O. So our limiting reactant is the carbon dioxide. The excess reactant is the hydrogen. And our theoretical yield is the carbon dioxide. So as what is asked here, how many moles of H2O could be produced? So we have 0.14 moles of H2O produced by the reaction of the problem number 2. So
That is problem number 2. And
let us now proceed to problem number 3. So when 5 moles of CuO is mixed with 3 moles of Ki2, how many grams of CuI can be formed? So same process. So step 1, let's have the balancing of chemical equation. So CuO plus Ki2 is to CuI plus K plus O. Let's balance it by having a 2 here, and then 2 here, and 2 here. And it is now balanced, guys. So in here we have 2 copper, 2 oxygen, and then 1 potassium, 2 iodine, and in here we have also 2 copper, 2 iodine, and 1 potassium, and then 2 oxygen. So next step is, so we need to put the moles here. So in the given, we have 5 moles of CuO. And for the Ki, we have 3 moles. And what is asked is the CuI. The next step is to convert moles of copper oxide to the moles of copper iodide. So we need to have 5 2 mole of copper oxide. So we need to cancel this out. Cancel. So it is equals to 5 moles of CuI. 5 moles of CuI or copper iodide. Next is to convert moles of potassium iodide to the moles of copper iodide. So we need to have Ki2 to CuI. So we have here 3 moles of Ki2. So 3 moles of Ki2 times 2 moles of CuI over we have 1 mole of Ki2. So it is equals to, we need to cancel this out. Cancel. So it is equals to 6 moles of CuI. CuI. So it simply means that our limiting reactant is the copper oxide or CuO. So let's put it here. And our excess reactant is the Ai2. And our theoretical yield is the CuO. And as what is asked, how many grams of CuI can be formed? In this case, we need to convert 5 moles CuI to grams.
Let's have it here. So we need to have 5 moles of CuI times. So we need to have the total mass of copper and the iodine.
So in periodic table of elements, for copper it has a 64 mass and for iodine it has 127 mass. So 127 plus 64 it is equals to 191. So let's put grams here. CuI over 1 mole of CuI. So let's cancel this out. So 5 times 191 grams CuI divided 1 is equals to 955 grams. Grams of CuI. So it is all. So the grams of CuI can be formed is the 955.
That's all, guys. So I hope you learned a lot today. So thank you for watching and God bless. Bye!